Okay, welcome to what I think is probably the last of the videos on this lesson. Hopefully you did what I suggested at the end of the last video and you explored a few other points on your calculator. You should have ended up with a diagram that looks something like this. I've missed off an arrow on this one, where lines and trajectories are starting or going backwards towards the 1, 2 eigenvector and heading towards the negative 1, 1 eigenvector. So as we go backwards through time before the initial point, we're heading towards that negative eigenvalues eigenvector. And as t increases, we head towards the positive eigenvalues eigenvector. The next idea then is to think about what happens as the eigenvalues change values. So we started off with one positive eigenvector value and one negative eigenvalue. We found that the positive eigenvalue had an eigenvector that went away from the origin. The negative eigenvalue had an eigenvector that went towards the origin. So let's take a look at an example where both of them are positive. So we have an eigenvalue of 1 for the first part of the general solution and an eigenvalue of 3 for the second. Write down the equation of the two lines through the origin that are parallel to the eigenvectors. This is the same idea as before. So for the eigenvalue which is 1, its eigenvector is 1 to the right and 2 up. Okay, so its eigenvector is going to look like this. Thinking about rise over run, it would be 2 over 1. So we would end up with a line that is y equals 2x if it goes to the origin. Thinking about the same thing with the second part, we've got going along 2 and down 1. Okay, so the rise over run would be negative 1 over 2 or negative a half. So that would be our second line. Describe the trajectory of any point that is initially on either of these lines. So what would happen if we choose a starting point that's on one of those lines? We need to think about the eigenvalue. The eigenvalues are positive, which means that that's the scale factor that our points are moving along. So as they're positive, it means that we're going to keep travelling along those lines. As t gets bigger, e to the t or e to the 3t get bigger, so the x and y values are going to increase as well. We're going to move away from the origin. So we're going to move away from the origin along the eigenvector. And we thought of that by considering the eigenvalues. So because those eigenvalues were positive, we're moving along the eigenvectors. For those trajectories beginning away from the two lines given in part A, write down the gradient of the trajectory that the trajectory will approach as t gets larger. So once again, we've got to think, well, as t gets larger, which of the two parts of my general equation is going to become more dominant? One of them isn't negative this time, so we have to think a bit more. But if t is getting bigger, 3t is going to be bigger than 1t. So the second part of my general formula, general solution, is going to become the more important part. It's going to become the larger value. So it means that is the eigenvector that it's going to head towards. Write down the gradient of the trajectory. So it's going to be this second gradient, which was m equals negative a half. Okay, and that comes from comparing the sizes of eigenvalues. Okay, so that larger, more positive eigenvalue is going to become more dominant. That's going to be the eigenvector that the trajectories are going to head towards. What point do all trajectories tend towards as t goes to negative infinity? Well, this time we've said that as time goes on, the points are going to move away from the origin. So if we reverse time a bit and head towards negative values, they're going to go back towards the origin. So the point that all trajectories tend towards is 0, 0. Tend to 0, 0. And they're going to do that along the other eigenvector. So if we have negative time, a negative t value, the larger of the two parts of our general solution will be the first part. We're comparing e to the t with e to the 3t. If we put in a negative value, say we put in the value 5, we want a negative value. Let's think of negative 5. E to the negative 5 is going to be bigger than e to the negative 15. So the first part is going to become the more dominant of those two. And the eigenvector that goes with that, 1, 2, is going to be the one that they follow. So they're going to approach it along close to the line y equals 2x. So let's have a go at sketching this quickly. We need some x and y axes. Here's my y. Here's my x. Okay, I need my eigenvectors. So my eigenvectors were y equals 2x. Roughly here. Y equals 2x, and they're moving away from the origin. And y equals negative half x. I'll try and make that kind of about, it should be at 90 degrees. I'll make it as close as I can. And that is also travelling away from the origin. All right, what have we just said? We've said as time gets bigger, they're going to go towards the gradient m equals negative a half. They're going to start in the origin, and they're going to start close to the other line, the other eigenvector. So they're going to end up looking something like this. Okay, so I'm starting in the origin. I'm trying to start off close to the, I guess we could describe it as the weaker eigenvector in this case, the one with the smaller eigenvalue, and I'm heading in the direction of the larger eigenvalues eigenvector. Okay, so that's what would happen if we have positive eigenvalues. Finally, what would happen if we had negative eigenvalues? So it's the same lines, we're just changing the eigenvalues from positive 1 and 3 to negative 1 and 3. If you want to stop the video, have a think, what would happen this time? So let's have a little sketch again. I should have left a bit more space for this, shouldn't I? Okay, I've got y. I've got x. I've got the same eigenvectors. So y equals 2x and y equals negative a half x. Okay, so as t gets bigger now, both parts of our solution are going to get smaller. So what's going to happen then is that we're going to be, we are going to be heading towards smaller values. We're going to be heading towards the origin. Okay, let's make a little note of that. Tend towards origin. Okay, and then what's going to happen as if we choose a point that's not on an eigenvector, well, it's going to look like this. It's going to head in along that y equals 2x line from the other line, and it's going to head towards the origin. again. Okay, so the phase portrait is going to look something like that. So if I take a point and I say, well, this is my starting point, this is t equals 0. As t gets larger, we're going to head towards the origin. So this is a value a little bit later. I don't know quite how much later it is, but it's going to head that direction. If I was thinking about going before t equals 0, I would be back here. This is t is less than 0. Okay, so both negative eigenvalues, we have them approaching 0, 0. Both positive, we have them moving away from 0, 0. And if we have one positive and one negative, we have one going into the origin and one coming out of the origin. Okay, there's a little bit of reading for you to do. In these examples, 0, 0 is an equilibrium point in the examples above. So if it's initially at the origin, it will stay there. In both cases, 0, 0 is an unstable equilibrium point because generally particles that begin close to the origin will move away rather than towards it. In the first example, 0, 0 was a saddle point. Okay, so that was this one. That's the name for that type of equilibrium point. It's a saddle point. Or sorry, it's not an equilibrium point. As we get towards the origin, in this, it's going to move away from the origin. In this one, it is a source, which is kind of a word that seems to make sense when we look at the diagram. Everything's moving outwards from there. And in 4F, okay, so this is the last one. 0, 0 is a stable equilibrium point. Okay, so we have a stable equilibrium point. If we reach the origin, because everything's travelling into the origin, we're not going to leave it. Okay, with the others, if we did somehow reach the origin, we're going to move away from it. Okay, there's a little bit of reading for you to do at the bottom of page 20 and the start of page 21. I would suggest you read through it. I think in particular, the notes on the top of page 21 are really important. I'm not sure you want to highlight all of them because it becomes less useful then, but those are some key summaries of this lesson.